Okay, good afternoon, kids. We'll discuss in today's class in the element chapter. The last topic is the galvanometer resistance by off deflection method. This will be galvanometer resistance by off deflection method. It's a very simple circuit. First of all, previous class we had a discussion on the galvanometer. There, what was the problem? What we had is like finding out the total resistance of a galvanometer. What do you mean by total resistance of a galvanometer? So if you take the galvanometer, what actually it is made up of? The galvanometer, it contains say like a current carrying loop, then a spring is connected. Some connections are made inside that. So everything will become galvanometer resistance, not only just loop, everything. So all will contribute the galvanometer resistance. The galvanometer resistance is contributed by too thin or thick. Galvanometer resistance is contributed by first, the major component which will contribute galvanometer resistance is the loop. Coil, I'll write it better. Coil, that one. Then next again, they're like a spring, of course, not there, and the connecting wires. Connecting knobs. So all these what happen will lead to a resistance. So this how to find out this one? So it's a big headache, no? So what you should do, find out the resistance of coil, finding the resistance of connecting wires inside to make a joints. That one. Then again the connecting knobs, very complicated all this one. So all together, but I want the resistance of a galvanometer. I want the resistance of a galvanometer. So how to determine it? How to determine it? So therefore, I should not open. The moment if I open galvanometer and if I try to measure the resistance of a coil, I'll be disturbing the configuration. So at any cost, I should not go for opening of galvanometer. So therefore, what is the alternative? Without opening galvanometer, I should find out the resistance. Are you getting now the challenging? So what is there? I'll measure resistance of coil, connecting wires, connecting knobs. Very difficult. These are, and the two knobs, they'll be of some very complicated shape. Lot of mass is involved. So better let's go for some method. So by without opening the galvanometer, we should find out the galvanometer resistance. Why galvanometer resistance is important? Anybody answers? Why it is important?
To find and remove the errors.
No, galvanometer is what used to construct ammeter and voltmeter.
Yes, sir. Okay.
We need exact value of G, no? Current intensity, go back to current intensity. To get the exact value of G is needed in, again, deciding the range of an ammeter. So there are so many interlinked things are there. So there's so many things are there which are interlinked with each other. So therefore, exact value of galvanometer resistance is what necessity for us. So then only I can go for ammeter, voltmeter. So therefore, for this, we have a circuit. Let me write this as galvanometer. So here I'll bring a variable resistance R. This galvanometer scale, it will be there. It will have some marking. And the resistance of galvanometer, let it be G. This is a cell of EMFE. A current I will flow. And the pointer will have deflection at this point. So what is the expression for this galvanometer current? IG is equal to E by, this is external resistance R plus G. Will I agree, all of you? And this IG is equal to K into phi. This K is called as a figure of merit. From where this, I think in the galvanometer construction, we made current proportional to the deflection of pointer due to all that one. So the remaining all that K is what? The figure of merit. So what is the K? K will become N, couple per unit waist, number of turns, area of cross section of the coil, and magnetic field. That everything will become figure of merit here. Even this figure of merit also very important for me. I can't measure individual number of turns, area, magnetic field strength. Can you measure magnetic field strength? Very complicated, big headache. So both galvanometer resistance as well as figure of merit has to be calculated. Why it is called as figure of merit? I think the galvanometer is good or bad. I had to give merit. All of you, word merit. Merit marks. I got. So like I passed it with merit marks. They say some very good. So the galvanometer is good or bad. What happened? We just say like a merit. The figure of merit. It say. Okay, both are very difficult quantities to measure. Galvanometer resistance and figure of merit. So what is the figure of merit? It contains, I think, couple per unit waist is equal to NIAB. Okay, don't get confused much here. Tell me, like in place of K, what we have? Couple per unit waist, number of turns, area, and magnetic field. B, very difficult quantity. Number of turns of coil. Okay, I can count it. Couple per unit waist. Not easily you can measure. Area of cross section. Okay, N and A, okay, fine. C and B, again, very difficult to measure. So to overcome this, we are bringing that figure of merit. Can you know, say everything, say like, whenever you find difficulty, you are trying to go for alternative. So this is this one and this B. C and B are difficult to measure. Let me start the next condition. Now what I do is like in the next part of the circuit, I'm going to bring one resistance in parallel such that the current through galvanometer, I'll make it off. That's what the trick. So what is IG dash? IG dash, I'll call it. So it will become off. So now look at the deflection. Now the deflection will become earlier off of it, it'll be. So this will be confusion a little bit. The arrow, I'll put it so exactly here. So exactly at off, I'll show it. So the value of S is so adjusted that, and the value of S is so adjusted that the deflection will become off. So how much of that current? Let it be IG. IG dash, I'll call it. Don't write that one. Let me call it as IG dash. So yeah, earlier was what was the deflection? This was the theta. Now it will become theta by 2. So for that, I'm going to adjust the value of S. So with this, we can find out the galvanometer resistance very easily with this experiment. Okay, I think it just it's a now the matter of current density concept. Okay, this current I is there. So what is the expression for I? I equal to E. So this will become R plus these two are parallel, no? So GS by G plus S. So now how much of current? IG dash should be equal to branch current method. I'll apply it. This one. So what is the current in this branch? What is the current in this branch? Main branch current into resistance of other branch by sum of these two resistance. So based on that, it will be I S by G plus S. We'll substitute the value for the IG dash. This will be equal to E into okay, this will be the call equation 1. So now what we should do? We are going to make the value of the galvanometer resistance has to be determined. So what is our main question like? The galvanometer resistance. So the how much of for deflection to become off, how much of this galvanometer current should become off of it? Should become off of it. Okay, now the calculations will begin here. IG dash should be equal to IG by 2. So what is IG? IG is equal to E by E by 2 times of R plus G. This is the equation 2. I'll write it. So let me equate both and let me solve it. Let 2 equal to 1. So then from that, E will get cancelled out. Solving this, RG plus RS plus GS equal to 2RS plus 2GS. RG is equal to will become RS plus GS. What is the G is unknown thing which has to be determined. So therefore this will become R minus S. G is equal to RS. So what is the final value of G? RS by R minus S. What shall I do now? I'm going to adjust the value of R. I'll keep one shunt resistance. I'll adjust value of R here. Okay, no doubt. Again, I should not change the same value of R. The value of S is brought here. Here I'm going to adjust it in such a way that the deflection, the galvanometer will become off. Once it becomes off, then I'll note down that particular value. Of course, sir, why you are putting this R variable? Because I have to make this deflection maximum. No? So the moment you connect it, you have to see that the current through the galvanometer should be maximum. For that, I should adjust the value of R. Now, this value of S with directly we cannot guess. We have to choose some value. If you keep on vary it, the point, the value of S at which the deflection in the galvanometer will become off. For that, say, can you, sir, why don't you measure current? Again, to measure current, some error will come. That's why we are taking this off deflection method. We can bring ammeter. Again, if you bring ammeter, I think there's some error will come because any measuring instrument will add some resistance. Ammeter means it will add resistance in this branch. Again, that has to be taken care. So this is more advisable. Please try to analyze. So this is the galvanometer resistance. So I need not to open the galvanometer and disturb the setup. Not advisable. Like this, finding out this one. So this is the more best method available for us. Okay, yeah, this one. Okay, now we got the galvanometer resistance. So I want the figure of merit also. So once I know the galvanometer resistance, then I'll go back to the this experimental one. I'll wind up here only. Determining the figure of merit. So what is value of IG? So then IG equal to K phi. This is what we know it. So let me equate these two. Then K phi equal to R plus G. So I'll measure the, I know applied EMF. So I'll measure the deflection, the galvanometer resistance. If I know it, I can bring the figure of merit. Now, what should be the figure of merit? It should be very high, should be very low. Who will answer? Yes, anybody? Figure of merit should be very high, should be very low. No response from anybody. Should be very low. Yes, yes. Ananta Krishna, yes, in fact. Why very low? Current sensitivity. How you define current sensitivity? Deflection per unit current. That's what no current sensitivity. For even a small current, if it shows very good deflection, then it is said to be more sensitive. So NAB current sensitivity depends on what? Deflection per unit current. NAB by C. So that current sensitivity should be I. For current sensitivity to be I, figure of merit should be low. So the value of figure of merit must be low for high current sensitivity. I don't know, in our books, they have modified this, like there's more stupidity here. The more resistors you bring, the more error. Am I right? Minimum resistances is what I should do. The more resistors, if I use, more error. We can also do this by connecting in series. See, like I'll hope everyone, if you completed, I'll just go for it. If you check the last year notes, I have just brought another circuit, but it's not advisable. I'll just bring other situations. But possibility of asking such thing in exam, that's why I just discussed. I'm discussing these ideas also. But actually in the lab, we don't prefer modifying the standard experiment. I'm making things clear. Suppose if the deflection is somewhere here, like some theta or anything, you can write it. I can show it clearly. No, this is theta. No, there's a galvanometer. It's having a resistance G. Here a current will flow. Say some I naught, or I just write it I. Then what I do is like Now I'm going to adjust this value in such a way that it will become theta by 2. That's all. So what is the current here? Current here should flow I naught by 2. What was earlier current through the galvanometer? I naught. Now it should be I naught by 2. For this, what I can do? I can bring a resistor here and I'll bring one resistor here. This is not advisable method. This is not advisable. You may end up numericals of this kind. Then if you know R1, then you can find out R2. Suppose that this R1 is there. So can we, or suppose R2 is there. Can you find out R1? So we have to write equation. So for the, what is I is equal to E by R plus G. So then can we make a guess of this I naught, like I height is there, no? So it is I by 2. The main branch current is how much, we don't know that one. The current to galvanometer is I by 2 because the deflection is now it is off. Okay, let's try to eliminate this I. So the equation for I will be, so I by 2 into G should be equal to say some I1 into R2. Then the main branch current, let me write it as here I2. I dash, I'll write it, that'll be better. So what is I is equal to? Looking at the diagram, I should be equal to E by R plus R1 GR2 by GR2. Now I can replace I dash. So what is I dash? I dash is equal to I into G by G plus R2. So this I dash I'm going to replace. We have to bring, okay, I have to bring a high 2, no? Yeah. So what is further I you can bring it as E by R plus R1 GR2 by I dash, sorry. I dash equal to this I dash value I'm going to substitute here. So this will become EG by on this side I'll substitute. Okay, we'll do one thing. I'll give a number. Again, after some time you'll get confused. So we'll give this equation 2. This is equation 3. Put 193 into 2. So this will become E by R plus G2 G. I dash will become EG by so E will get eliminated. Okay, this EG R21. Okay, we are. So EG gets eliminated. So solve for again G in terms of R, R1, R2. What is the problem? Why this is not advisable? Some books they're given only. I think some in Indian author books I saw like this questions. But let's see that. We'll see where we'll land up. So this will become 2R plus G is equal to EG get cancelled. So R2 is equal to 1 G plus R2 will get cancelled out. So R plus R1 Nothing very lengthy. We have to solve for G. What is it? We can find out by this method also. What is the headache? Are you the value of G? What we have brought it? R minus S. No, there'll be some error in measurement of R and S. So definitely an error will come. So, and what is needed? This error in the G should be as minimum as possible. So therefore, what do you expect? Do you like more values, more parameters here? Do you want G to be dependent on more number of quantities or less number of quantities? This is quite easy. No, we'll end up answer, and the error will be minimized here. What about your error? Will be very large. Okay, let me solve it. Then you'll understand the RG plus RR2 plus R1G plus R1R2 plus GR2. So it should be equal to 2GR2 plus 2GR plus 2GR2. One R that will get cancelled out. So this will be RG1 here GR and here GR2 will cancel out. So I'll end up with RR2 plus R1G R1R2 equal to RG R2G. So all G terms on one side. RR2 plus R1R2 is equal to R1 plus R2 plus R3. Final value of G. I need some place. Let me put in order again. This can be asked in some books they're given, but not advisable. Not advisable, because the more number of G depends on more number of quantities, more errors will come. Okay, finally, what is the expression for G? R1 2GR2 plus RR2. Okay, well, I think RR2. To GR2. Okay, I think I'll change from here then. This is okay. LHS will be RG RR2 R1G R1R2 plus GR2. Okay then. Now this will be 2RR2 2GR2. Again GR2 one get cancels. RR2 one will get cancels. So I'll end up with GR plus GR1 GR2 is equal to GR2 plus RR2. Year one GR2 will not be there. Here GR2 will be there. So finally, this will be G equal to RR2 by R1 So what is the problem with this? We'll get answered. What is the problem here again? You have to choose R1, R2 values in such a way that the deflection, the galvanometer should become off. Okay, fine. We can do everything is fine. We are very good in math. Somehow I brought it. But what is the headache? The headache is like the error will be more. Are you able to understand this? The error will be more because again, the value of G depends on R, R2 and R1. Earlier it was only R and G. It's like R and S. So in exams, but they can ask you. But in lab, we don't prefer it. Nobody does in the lab. You must be ready for the modification of these things in advance or the mains. These are the equations 1, 2, 3. So just when you're going for exam, no, just recollect these things are not there in book, like in our standard books, which are there, no, not there. But if you refer some other books which are not there for JEE Advanced, no, we do have several methods. These are one of the method preferred, but not advisable. Nobody prefer that one. The first one, what I discussed, is the standard method. But possibility of asking. So in exam, I don't think so you can make any guess of this. You have to work out. Okay, I'll end up the class. I have a junior 4 o'clock. We'll meet again on Monday. Okay, now I'll think got it. Something has happened. Yeah. Okay, thank you all of you. We'll meet in next class. Okay, thank you. Take care. Bye. See you.